the base e. Y is equal to the log of x to the base e. This is called the base. This is a number, and this is exponent. It can be changed to the exponential form of this base raised to that power is equal to this number. So listen closely. The log of a number is a power. The log of a number is an exponent. It's the exponent of the base that gives you that number. And if it's ln, then it's base e. So if you see ln somewhere, then you're supposed to automatically know that that base is an e. You don't have to write it down, but you need to know that. To change from a logarithmic form to exponential, you take this base raised to that power is equal to that number. Now, the second thing about logarithms, let's look at the sketch of them. All right, so I have y is equal to the log of x. Well, if I let x be 0, there's no answer to that. If I let x be, well, let's go back and look at this. Let's back off and look at this with the graph. Okay, so if I let x be 1, the log of x, okay, the log of 1 is 0. Log of 1 is 0 because e to the 0 power is equal to 1. E to the 0 power is equal to 1. Now let's let x be 2. What power of e would be equal to 2? Well, it'd be less than 1. And out here, and so what you get for the graph of the log of x is a curve like this. It goes forever, and down here it never touches 0. Now let's see why. If I have e, and e is a number 2.71829 blah blah forever. If I raise that to the first power, I get 2. If I raise it to the 1/2 power, okay, then I get a number smaller than that. Let's say 1 point something. If I raise it to the 1/10 power, I get 1 point something. Well, that means I never can, x will never be negative, so there's no curve over there. And it also means that, well, let's see, what would I get if I made this a -1 power? If y was a -1, well, I'd get 1 over 2.7183. So what's happening is when x is between here and here, you're getting a negative power that makes it less than 1. So when this is in here, you get y to be negative. But it will never reach 0. Why? Because 1 over 2.71829 to some power is going to still be equal to a number. You can't get exactly 0 unless this thing is approaching infinity. And when it's approaching, well, that's what this is doing. When this is going down here, it's approaching infinity. So 1 over infinity is 0. So it can get very close to 0, but not exactly 0. All right, let's look now at when it's written as log. Okay, if we have y is equal to log, the log of 1,000 to base 10. Now, when you want any base except e, you use log, and you write down that base. Now again, if it's not written, if a problem does not have a base written here with log, then it's base 10. But if you want to log to base 2, then you put log base 2 and work it out. So we use log for any base except e. All right, looking at changing from the log form to the exponential form, it says take this, raise it to that power, and it's equal to that number. And this is how you can solve that, to find what y is equal to. What you do is change the bases to be the same. When you get these bases to be the same, then you just read the answer off up there, y is equal to 3. Or you do this. What power do you raise 10 to get 1,000? The answer is 3. Looking back here. The log of 1,000 base 10 is what power do you raise 10 to get 1,000? So that's 3. All right, last thing about the LOG is still the same process of 1. The LOG of 1 is 0. And so what you get is the exact same, basically the same curve. Now the difference is one of them gets there a little quicker, a little lower here, but basically they're still the same. They come across over here and cross at 1. The LOG of 1 is 0. The LN of 1 is 0. The log base 2 of 1 is 0. The log of any base of 1 here is 0. Okay, now let's look at some facts that you need to know. And there, the first row says the log of E is equal to what? Well, let's look at E raised to what power equals E? Well, E to what power equals E? Well, it has to be a 1. So the log of E is 1. The log of E is 1. Memorize it. Just know it. You'll run across it over and over and over again. The LOG of 10 is 1. Because 10 raised to the first power is equal to 10. All right, the next one that you'll run across many times. What's the log of 1? Well, that's 0. E to the 0 power is equal to 1. So the log of 1 is 0. And it doesn't make a difference whether it's LOG. The log of 1 base 10 is also 1. So the log of 1 is 0, no matter what the base. The log of 1 is 0. Now, when I say no matter what the base, we need to understand in this tape that we're talking about LN and LOG of just regular positive bases. We're not talking about special cases and other math courses. We're talking about just where this is a positive base right here. All right, the next one. What is the log of 0? And that is not possible, because you cannot take E, which is a positive number, and raise it to any power and get back to 0. So the log of 0 is not possible. And then the last one, the log of a negative number is not possible, because you cannot take E, which is a positive number, and raise it to a power and get a negative number. Okay. Powers kind of mean you multiply it by itself. So if this is a positive number, I'm going to multiply it by itself. I'm going to get another positive. Therefore, the log of minus numbers do not exist. And that's why you're going to see in the rule about derivatives, we're going to put absolute values here around these so that we can change that sign and make it a positive and get answers, because the log of negative numbers do not exist. All right, now let's look at some more facts you need to know to be able to work problems in the application of derivatives of logarithms. Is changing exponential. Let's solve this, okay? I'm going to teach you two different ways of doing it. Number one is the mechanical way. We take this, raise it to that power. So changing the exponential form is 2 to the y power is equal to 8. Now what was the rule I gave you before? That's to get the bases the same. So this is 2 to the y power, and 8 is 2 cubed. Now that we have the bases the same, then the answer is y is equal to 3. The other method is to reason it. 2 to what power equals 8? 2 to what power equals 8? The answer is 3. All right, next one. Now the log of 27 to base 1/3. So we say 1/3 is to the y power as equals 27. Well, let's see. We need to change this to be the same. So we'll move the 3 up, and that requires it to be a negative power. And we'll take the 27 and write it as 3 cubed. So we have the base is the same. Read the answer. So y is equal to minus 3. Now, let's go back and look at the reasoning on this. 1/3 raised to what power is equal to 27? Well, first of all, if you have to flip a fraction over, it requires a negative sign. Then 3 to what power gives us the 27? 3. All right, now the negative, when you see a negative here, what you're going to see is this. One will be a fraction, less than 1, and the other will be greater than 1. They'll switch around. Okay. To do that, to go from a fraction to less than 1 to a number greater than 1, it's going to be a minus something. Or vice versa. If you go from a whole number here to a fraction, less than 1, then that means the power will be a negative something. All right, next example. Okay, the log of e squared can be written as 2 times the log of e. We can take that power and move it out. And so what's the log of e equal to? Log of e is 1. E to what power is equal to e? 1. So the final answer on that is 2. Another way of doing this is this process. Consider this as a y right here and go work it. This says e to what power? So e to the y power is equal e squared. Base is the same, therefore the answer is 2. All right, let's look at now some examples. All right, now let's look at some laws or rules of logarithms that we need to know. All right, first of all, this example, the log of times and division. The log of multiplication is the log of 5 plus the log of x plus the log of y minus the log of z. Log of multiplication is addition. Log of division is subtraction. All right, that's the first 2 rules. The log of multiplication is addition, and the log of division is subtraction. All right, and the third rule, let's look at this example. This would be the log of x squared plus the log of the square root of y minus the log of z cubed. Now that's the first rule. The second rule, multiplication. The third rule is this. The log of a letter raised to a power, the power can be moved out in front. So this would be 2 times the log of x plus, hey, what's the power of this? The power of this is 1/2. So it would be 1/2 the log of y minus 3 times the log of z. Now there are your 3 rules right here in this example. The log of multiplication is addition, the log of division is subtraction, and the log of a letter to a power can be moved out, the power can be moved out in front. All right, those are 3 laws of logarithms that you need to know. Now I want to talk about this one right here. The log of addition is not anything. You cannot distribute this word in there among those. Okay, it is not the log of x squared plus the log of, you cannot do that. There's no rule for the log of addition or subtraction. If these are multiplied, then you can use a rule on them. There is no rule for the log of addition or subtraction. All right. Let's look at some other things. These are common mistakes that students make. Right? The log of x squared is 2 times the log of x. If we have the log of some number right here, raised to a power, we can move the power out front. But this one is not that rule. this says that the log of x, all of this stuff together, is squared. You see, technically, this is the way they should write it in books. But they don't do that. They save time and ink and trouble by moving that 2 in there. And you don't get to move that out. That 2 has to be the power of the x there. And the reason for that is this. The log of x squared is the log of x times x, which is what? The log of x plus the log of x, which is how many? 2 of them. See, all these rules are based on the 3 I just gave you. The log of multiplication is addition. The log of division is subtraction. And the log of a number raised to a power, the power can be moved out in front. But don't foul it up now with this right here. That is not the same thing. All right, now some other known facts. And that's this. E raised to this power, E raised to the power of the log base E is just whatever this object is. Just whatever that is. You just get to write everything, erase everything, and just write that down. Looking at this one. Says that if I have this number raised to a power of the log of the same base, then the answer is just x to the 6. You just get to replace it. See? So 3 log base 3 of is whatever this is right here. Okay? You just get to throw that away and say that's the answer to it. Just memorize that. All right, now let's look at 2 cases where we can use logarithms to find answers for x that we haven't been able to before in mathematics. To do something like this, to figure that out, you know, we haven't had rules to find out what x is there. So here's what you do. You take the log of both sides. So we'll take the log, base E of 2 to the x is equal to the log of 3. If we take the log of both sides, we're going to take the log of that, log of that. Well, now here's where we use our rule. The log of a number raised to a power. I can move that power out in front. And now solving for x, I divide both sides by the log of 3 divided by the log of 2. Now don't make a mistake here. The log of a number divided by the log of a number is not one of the rules. The rule is the log of a number divided by here. The log of that is the log of 3 minus the log of 2. This is not that case. This is not that. So what you have to do to solve this one is go take a calculator and look up the log of 3, which is 1.0986, and the log of 2, which is 0.693. Take a calculator, divide that out, and get your answer of 1.585. Well, that's a sensible answer, see. 2 to what power is equal to 3? Well, 2 to the first power is 2, and 2 to the second power is 4, so it must be somewhere between there, and it is. All right, let's look at the next example. 23.51 to the x power is equal to 5. All right, well, we'll take the log of both sides. And again, I can take log if I wanted to. I can take the log of both sides. All right, moving the x out in front, then x is the log of 5 divided by the log of 23.51. And so you write down the log of 5 and the log of 23.51, and you get 0.51. Now let's see if that's sensible. Okay, 23.51 to the first power is 23.51. So second power would be larger than that, so we're going to go back that way. 1/2 power. What's the 1/2 power? 1/2 power is a square root. 1/2 power is square root. Square root of that is pretty close to 5. So the answer should be pretty close to 1/2, and sure enough, it is. All right, now these are the facts that you need to know and the rules and that type of thing about logarithms. Now the rest of the tape on logarithms is the derivative of them. So let's look at some examples. All right, examples of derivatives, derivative logarithms. All right, derivative of y is y prime. Derivative of log, derivative log is 1 over the object, whatever that is, just 1 over that, just write that down, times the derivative of the object, which would be 2x. Okay? The derivative of logarithms is 1 over whatever this object is, times the derivative of that object. 1 over the object, and then you simplify, and you have y prime is equal to 2x over x squared plus 1. All right, let's memorize it that way. The derivative of a logarithm is 1 over the object times the derivative of the object. All right, let's look at example 2. Example 2 says, all right, derivative of this is y prime. The derivative log is 1 over the object. Just copy it down. Whatever this is out here, 1 over that, and then times the derivative of this, which would be 2. So simplifying that, we just move the 2 up on the top. And we have 1 over the object times the derivative of the object. Next example. The derivative of this is y prime. The derivative log is 1 over the object times the derivative of the object. The derivative of this, just look at this now and take the derivative. Derivative of 9 is 0. Derivative of x squared is 2x. And so we come down and simplify it and move the minus 2 back on top. But the derivative of logarithm is 1 over the object times the derivative of the object. All right, example 4. Okay, this would be y prime. Derivative log is 1 over the object, so it's 1 over 5 minus 2x plus x cubed times the derivative of the object. Derivative of 5 is 0. Derivative of minus 2x is a minus 2. The derivative of x cubed is plus 3x squared. So again, we come back and we simplify that one and write it as minus 2 plus 3x squared all over the object 5 minus 2x plus x cubed. Okay? Now let's look at example 5. Now example 5 is a product rule first. Product rule. So derivative of y is y prime, product rule. I'll write the first one down, take the derivative of the second one. The derivative of the second one is the derivative log. 1 over the object, 1 over whatever this is, 1 over x, times the derivative of that, which is 1. Plus, now I write down the log of x, I'll write it over here, and I take the derivative of the first one, which is 2x. Now, I think if you'll learn to do this, you'll be a lot better off. Don't write down the log of x and then come over here and write down the derivative next to it. That looks like that goes with the log. So learn to put that out in front of the log. Now, don't forget to simplify, all right? This x will divide in this one time, and so we get x plus 2x log of x. All right, next example. Now, the next example is the power rule first. Example 5 was the product rule. Now we're going to look at the power rule. The derivative of the log of x squared. The log of x squared is the power rule. This all goes together. So it's the power rule. So y prime is equal to 2 times the log of x. You see, now look at this. This is the same thing as, in parentheses, the log of x squared. So it's the power rule. So it's move the 2 down, subtract 1, and then take the derivative inside the parentheses, which is the 1 over x times 1. Now see again, don't put this next to that. It looks like I can cancel. This goes out in front. The answer is 2 times 1 over x times the log of x. All right, now watch. The power rule, I'll move the 2 down, make it the first power. There it is, 2 down, first power. And then times the derivative inside. The derivative log is 1 over that, and then the derivative, that's 1. So don't get this messed up now. This is a power. If you have a log to some power, then you're going to power rule it first before you take the derivative of the log. All right? Example 7 shows this some more. Okay, example 7, we have y prime. This is the power rule. So I'll move the 4 down, make this cubed. Just write all that down, cubed. And now we're going to look at the derivative inside. What is the derivative of this now? The derivative of this is 1 over the object, 1 over 3x squared, times the derivative of this object, which is 6x. Now what happens, a lot of this simplifies. Let's see, the 3 will go into this 6 2 times, and this x will divide into that. And that leaves us 2 times 4 is 8. Log cubed, all divided by x. Okay, let's look at another example. Go into example 8. This is a division rule. The division rule. So this says y prime is equal to, let's see, I'll write the bottom one down. So log of 4x plus 1 times the derivative of the top, which is 3x squared plus 2. And then minus, I write the top one down. That's x cubed plus 2x. And take the derivative of the bottom. The derivative of the bottom is 1 over the object, 4x plus 1, times the derivative of the object, which is 4. All over, now watch, all over the bottom one squared. If you square a cube logarithm, that's how you write it. All right, well, we can simplify this, I guess, by getting a common denominator up in the numerator. Here's a denominator, multiplying that over. So we'll have 4x plus 1 times 3x squared plus 2 times the log of 4x plus 1. All that minus 4 times x cubed plus 2x all over 4x plus 1. And then that's all over the log squared of 4x plus 1. And then that final simplification is you just move this up into this denominator. In other words, you have one denominator, which is 4x plus 1. Now don't divide that out of there because this is a subtraction problem here. You don't have a 4x plus 1 over here, so you can't reduce that. Okay, let's look at now example 9. Example 9, we've got all the rules now. Example 9 is just another product rule. So we go take the first derivative, write the first one down, take power rule, power rule, power rule. So I move the 2 down times the log of the first power, and then I take the derivative of the log, which is 1 over 5x. Then I take the derivative of the object, which is 5. All right. Then that's plus. Then I got to go take the derivative of the x cubed, 3x squared times the log squared of 5x. Now we can come back and simplify this. Now let's see, the 5 here and 5 there, that divides out, leaves us a square. 2 here, so final answer would be 2x squared log of 5x plus 3x squared log squared of 5x. Okay, that's the rules for the derivative log. It shows you the product rule and quotient rules and power rules of logs. Now let's take up some more examples. Look at example 10. Here I have the log of a log of an x. Okay. Well, this is our last thing to learn. And that's, what do you do about the derivative log of x, log of x? Okay, the derivative of this would be y prime. Now, you go from left to right. You take the derivative. What you do is look at this as that's the log of that object. That's the object. So the derivative of this log is 1 over log of x. And now you don't look at that anymore. You now look at this. You take the derivative of that object. This is the object, so we now take the derivative of that. Derivative of log of x is the same rule, 1 over x. Okay, but we tag on in the bottom ln of this base. ln of this base. Remember, if we write down log with nothing there, it's a 10. Okay, so we say the derivative log is 1 over the object, and we tag on ln of 10, and then times the derivative of the object, which is 1. The derivative of the object is 1. So the final answer on this then is 1 over, how we want to write that thing? I guess we write it this way, x log of 10 log of x. All right, so the last rule then we need to learn is if we take the derivative log, we have to tag on an ln of 10 in the bottom. All right, let's look at some more examples. All right, some more examples. This is just like the first example where we had ln. All I'm just saying here is what we've already said. The derivative of log, derivative log, is 1 over the object times the derivative of the object, but then we tag on the bottom ln of whatever the base is. So in other words, our final answer here is 2x over x squared plus 1 times the log of 10. Just remember now, the derivative of log is the same as ln. You just tag on ln of whatever the base is. All right, let's look at some kind of algebras and complications now. Let's look at example 12. We have the log of the log of the log of 3x squared. So again, we work from left to right. So we're going to take the derivative of this log. All right, so it'd be y prime. Derivative of this one is 1 over the object, which is all of this. So that's the log of 3x squared. Now remember what I told you? You now look at this down here. Don't go back and look at the problem. Look at this and take the derivative of this. Well, there's that log. So the derivative of that log is 1 over log of 3x squared. And then you look at that. Derivative of that is 1 over 3x squared. And remember, you tag on ln of 10. And then you take the derivative of that, which is 6x. So your final answer is 6x all over the ln of the log times the log times 3x squared log of 10. Anyway, this x will divide out, and a 3 will divide out, so it can be reduced to that. All right, let's look at the next example. Example 13 says the log of division. Log of division, which says, I'm not going to take the derivative yet. I'm going to say y, same stuff, is equal to the log of x minus the log of x plus 1. If you have the log of division or multiplication, expand that before you take the derivative. Now the derivative of y is y prime. The derivative of log of x is 1 over x. And the derivative of this log is 1 over x plus 1. Now to get that simplified, you can go get a common denominator. And what happens when you get a common denominator, you're going to get this. Okay, but this is what I'm saying to you here. If you have a log of some complicated mess here, used, because if we didn't, the derivative of that would be 1 over all that mess, and then the derivative of that, which is a quotient rule, which would be all this mess over here. Do all that algebra, and you come back to that. So if you have the log of a complicated problem here, expand it by the rules of logarithms. All right, for instance, example 14 is showing us that. Here we have the log of something. So this is, we're going to rewrite this as y equals 1/3 times everything. Here's the 1/3, the cube root, of the log of all this mess. X plus 1 squared, x to the 4th over x to the 7th plus 1 to the 5th power. Now we're going to do all that by the multiplication is addition, division is subtraction, power rule. So this is going to be y is equal to 1/3 times 2 times the log of x plus 1 plus 4 times the log of x minus 5 times the log of x to the 7th plus 1. Now we'll take the derivative. Y prime is equal to 1/3. Okay, so this will be 2 over x plus 1. This will be 4 over x. And this will be minus 5 times 7x to the 6th all over x to the 7th plus 1. Okay? So if you have the log of a complicated mess, then expand that out by the laws of logarithms. Multiplication is addition, division is subtraction, and a x to a power can be moved out the front. The log of x to the 4th, the 4 can be moved out in front. Okay, so now let's look at some other examples where the rules that we learned on the first page of the notes are useful. For instance, the derivative of this is, wait a minute, that's e to the power log base e. If these are the same, then we just get to replace it with x squared. Therefore, y prime is equal to 2x. Look at example 16. If these two numbers are the same, then you just get to replace all this with x to the 6th power. And now you go take the derivative. Y prime is equal to 6x to the 5th power. So here's a case where, just watch for that. You usually get 2 or 3 of those somewhere in a textbook. All right, now let's look at the next example, 17, at implicit differentiation. Just all that mixed up together. Same stuff, product rule. Here's a product rule. So I'm going to write the x squared down and take the derivative of the log. Well, the derivative of the log is 1 over the object, which is xy plus 5x, times the derivative of the object. That's product rule, so I write x down, take the derivative of y, which is y prime, plus write the y down, take the derivative of x, which is 1, plus derivative of 5x is 5. All right, now that's just the part of the product rule. We've got to now say plus, write all this down and take the derivative of x squared, which is 2x. And then I write down the log of xy plus 5x equals. All right, equals the derivative of this. Derivative of this is, derivative of log is 1 over y squared. Now look there, what's the derivative of that? That's 2y. Anytime I take the derivative of y, I tag on the y prime. All right, so watch that one. Look at it again if you need to, but look at the notes and get down what's going on here. This is just what's called implicit. We're going to take the derivative of all that. But the rule was, anytime I take the derivative of log, it's 1 over, and then the derivative of that. And every time you take the derivative of the letter y, you do what? You tag on a y prime. All right, now let's look at one application of using derivatives and logarithms. We want to find the maximum, minimum, and the equation of the tangent line, all right? So find maximum, minimum, take the first derivative, set it equals 0, and solve, all right? So here we go. The derivative of this would be, write the first one down, take the derivative of that, which is 1 over x, plus, write the log of x down, take the derivative of x, which is 1. All right? Simplifying. 1 plus the log of x. Now, how do we find max and minimums? We take the first derivative, set it equal to 0, is equal to the log of x. Now, this is why we start at the very first part of this tape. How do we solve for x? Well, here we go. We take e raised to that power is equal to x, and there it is. That is the point that we're looking for to be a maximum or minimum. Well, let's figure out what the y value is. Remember, our equation was x log of x. So if we come in here and put an e to the minus 1 here, e to the minus 1, and we put an e to the minus 1 here. Well, now look what happens here. Now, let's forget about that over here. This one right here. I get to move the power out in front. So let me erase this and say this. The log of e to the minus 1. I get to move the minus 1 out in front. And then what was one of these memorized? The log of e is 1. So it comes all the down to a minus 1. So let's go back now. E to the minus 1, log of e to the minus 1. All of this is a minus 1. So our y value is minus e to the minus 1. So there's our possible maximum or minimum. All right. To determine maximum, let's take the second derivative. Second derivative would be 1 over x. 1 over x. Derivative 1 is 0, and derivative log of x is 1 over x. Now, if I put e to the minus 1 is like 0.347. It's a positive number. 1 over a positive number is positive, therefore this is a minimum. And then graphically, if you notice in the notes there, graphically over here at 0.37 down a minus 0.37, we have a minimum point. All right, now the other part of this question says we want to find the equation tangent line at x equals 3. All right, so over here somewhere at x equals e, we want to find the equation of that line that's tangent that curve over here when x is equal to e. All right, let's go back. I'm going to rewrite this. The first derivative was 1 plus the log of x. All right, to write the equation tangent line, we want y minus the y value is equal to slope times x minus the x value. Well, the x value is e. What's the y value? Well, let's go back. The original problem was y is equal to x log of x. You find this number from the original equation. Here it is. When x is e, we get e here. We get the log of e. What's the log of e? 1. So y is e. So when x is e, y is e in this problem. Now what's the slope? Slope is the first derivative. So if I put an e in there, we get what? The log of e is 1. So we have y minus e is equal to 2 times x minus e. So y minus e is equal to 2x minus 2e. So y is equal to 2x minus e. All right, what this one's showing is this comes from the first derivative, this comes from the original equation, this comes from being given. All right, now let's look at the last example. All right, now what this is wanting is the derivative of an unknown to an unknown power. Now watch what we've done in the past. We've had an unknown raised to a known number. And we did what? Power rule. Move the 5 down, subtract 1. Then we've learned, no, we haven't learned. This will be the next tape. The next tape will learn what you do with if you have 2 to the x power or e to the x power. Okay, then there's a rule for that. What I want you to teach you now is what do you do if you have an unknown to an unknown power. So let's look at the example and note. Okay, we have y is equal to an unknown power. Now what we do is take the log of both sides. Log of both sides. Log of y is equal to log of 2x to the x power. Now remember what we get to do with a power, the log of a number raised to a power. We get to move that out. So we have the log of y is equal to x times the log of 2x. If you have an unknown to an unknown power, you take a log of both sides, and then you move this down out in front, and now you take the derivative of both sides, product rule over here. The derivative of both sides. So the derivative of that side is 1 over y, tag on a y prime. The derivative of this side is a product rule, so that's x times. The derivative of log is 1 over 2x times 2, plus the derivative, write this down, take the derivative of x, which is 1. So it's 1 times the log of 2x. So let me move over here and simplify. Now look, 2's drop out, x's drop out, so that all comes down to 1. So let me rewrite that. That'd be 1 over y. Y prime is equal to 1 plus log of 2x. Now, look what happens. We're solving for y prime, so I'm going to multiply that y across. So y prime is equal to y times this. Right? And then you rewrite what y is. What y is whatever the problem was to start with. And that's how you do unknown to an unknown power. Now you're always going to get, when you have an unknown to an unknown power, you're going to get that same thing you started with again, times the right side derivative part. Alright, this concludes the tape then on the derivatives of logarithms. The rest of this tape will be the derivatives of e to the x. Alright, this tape is about the derivative of exponentials. E to the x, or a to the x, which is 2 to the x, 10 to the x, 5 to the x. Any known number, and e is a known number, it's a special number, 2.71829, blah, blah. So if we have a known number raised to an unknown power, this is the process on this one. Alright, the first thing let's do is get in the mind the graph of e to the x. We'll use this at different times in application problems. So the graph of e to the x is this. If I let x be 0, x is 0 right here. E to the 0 power is 1. So it'll cross at 0, 1. Now if I let x be 1, then that's 2.7. So when it's 1, it's up here at 2.7. When it's 2, it's squared. That's 7 point something. So it really jumps up quickly. So this thing comes up very fast. Now when when x is a minus 1, then that's 1 over e, which is 1 over 2.7, which is 3.47. So when it's minus 1, it's a fraction, and then it becomes small and gets close to 0. Never touches 0, but gets small quickly. All right, now, if we have 10 to the x, or 2 to the x, or 5 to the x, then we get almost the same graph. All it does is changes whether it comes up a little more rapidly and approaches it more rapidly. In other words, 10 to the x would get up here faster, and it would approach 0 faster. So it's basically the same curve, which is crosses at 1. Okay, so that's the basic curve for e to the x, 2 to the x, 5 to the x, and so on. Crosses at 1 on the y-axis. All right, now let's look again in the notes there at the beginning, and let's learn the derivative. Here's what the derivative of e to the x is. The derivative says, just write the object down. The derivative, you write itself down. And then you take times the derivative of the power. So the derivative of e to the x is itself. Just write it down again. Then times the derivative of the power. Now, the next one, if it's not an e, then we do the same thing. The derivative of 10 to the 5x is itself times the derivative of the power, which is 5, and we tag on the log of 10. Now really, what happens, watch this, if we have y is equal e to the 7x cubed, okay, the concept is itself, we just write itself down. Then we take the derivative of the power, which would be 21x squared, and then we tag on the log of whatever this number is. But the log of e is 1. So when we do the derivative of e to a power, we don't tag on the log because that's the same thing as 1. So we're still really tagging on the log of this number right here. This is what's called a base. But on e to the power, we don't write it down. So let's say it one more time, then we'll do all the examples there in the notes. The derivative of e to the x is e to the x times the derivative of the x. The derivative of e to some power is itself, just write it down, times the derivative of the power. Very simple process. All right, let's look at the examples. Example 1, derivative of y is 1, tag on the y prime. Derivative of e to the x is itself times the derivative of the power. Okay, so final answer then is e to the x. All right, number 2, y is equal to e to the 3x plus 4. Derivative of y is 1, tag on a y prime. Derivative of e is itself, so we just write it down, times the derivative of the power. And then learn to come and take whatever this derivative power is and put it in front. And really you could do that all in the same step. The reason I write it down this way is to get in your mind the concept. The concept is the derivative of e to some power itself times the derivative of the power. And basically you ought to put that out in front. All right, next example. The derivative of this, derivative of y is 1, tag on a y prime. Derivative of e is itself times the derivative of the power. So the final way it should be written is 2x e to the x squared. Example 4. Now what this one is just product rule. Okay. So derivative of y is 1, tag on a y prime. Write the first one down, take the derivative of the second one, which is itself. Derivative of the power is 1, plus, write down the e to the x, and take the derivative of the first one. Now I want you to remember this for applications, that whenever you have a product rule or a quotient rule that has e to the x in it, then you'll always have the e to the x in every part, so you can come back and factor it out and solve for the x part. This will not give you max minimum parts, but what's factored, what's left when you factor the e to the x out, using that you can find max and minimums, points and inflections, and other applications. All right, let's look at example 5. Now example 5, we're getting away from the e. We're going to do several that have 2's or 3's or 10's here. Same rule. Derivative of y is 1, tag on a y prime. Derivative of e to the x, 3 to the x is itself, times the derivative of the power, and tag on the log of 3. So the final answer is 3 to the x times the log of 3. All right, next example. Y prime equals, just write this down, times the derivative of the power, which is 3, tag on the log of 5. So final answer is 3 times 5 to the 3x plus 4 times the log of 5. Okay, next example. Number 7, y prime equals Derivative is itself times the derivative of the power times tag on the log of 10. All right, and then example 8. What I'm doing here, if you notice, some of these are the exact same ones that other first examples, except they had e's. Now I'm doing it with a 2 or 3 or 10 in here. So y prime, write down the first one. Derivative of the second one is 2x. Derivative of x is 1. Tag on log of 2 plus derivative of x squared is 2x. Excuse me. 2 to the x power. Okay, let's look at example 9. All right, now this one, I want you to notice that this is still a known number, some number raised to the power. So the derivative of this is y prime is equal to it, itself, times the derivative of the power, which is 1, tag on the log or the parenthesis 5e. Now what you need to know is the algebra that you're going to see answer in the back. This can be expanded. Okay? So we'll write down 5e to the x, and then this is the log of 5 plus the log of e. The log of multiplication is log plus log. So what we're going to have here then is the log of 5 plus 1 times 5e to the x power. All right, now this problem could have been done by doing, this is the best way, but it could have been done by changing 5e to the x to 5 to the x, e to the x, and then do a product rule. Okay, now just watch how this ends up being the same. A product rule, I write this down, take the derivative of that, well, that's itself, times derivative of the power, tag on, well, I don't want to tag on anything, plus, all right, then we'll write the e to the x down and take the derivative of the 5 to the x, which is itself, derivative of x1, tag on the log of 5. Now, when we factor this out, we have left 1 plus. And what is this? This is the same thing as that, so you get the same answer. Okay, let's look at example 10. This is a big complicated product rule, this times the parentheses. So here we go. Derivative of y is y prime. Let's see. I'll write this one down first. And take the derivative of this. Derivative, it's e is itself. And then we take the derivative of the power. Derivative of the power is 1, tag on a y prime, plus 3x squared. Plus, now we write down the first one. So we write down, write down the second one, e to the y plus x cubed, and take the derivative of the first one. The derivative of the first one is itself times the derivative of the power. The derivative square of x is 1 over 2 times the square root of x. Okay? Example 11. Okay, in example 11, this is something you need to pay real close attention to in papers that I type up or people type up on the computer here. Sometimes you've got to pay very close attention to how that's typed. What this is e to that power. Now sometimes it may look like this. It's 1 over e to the third power. Okay, so, and I'll show you another one like that. So we've got to watch out for that. So this is e to this power. Okay. So that is y prime is itself 1 over x, that, and then times the derivative of that. Well, let's go back and look at that. What this is e to the x minus 3 power. You see, if you move a number to a power up, you change the sign of the power. So what we're now doing, when we write it this way or think it this way, then that's easy derivative. That's a minus 3x to the minus 4. So the derivative of e to this is itself, and then the derivative of the power. So final answer on something like this would be what? Minus 3e to this power all over x to the 4th. All right, let's look at the next example. This is the example now looking at the difference between these two. And what this means is 1 divided by e to the x cubed, or e to the minus x cubed. Big difference now. This is minus all of this, not a minus 3 power. So the derivative of this is itself, e to the minus x cubed. See what I'm doing? And I'm taking all of this and moving it up and changing this power to a negative. So it's itself, and then times the derivative of that, which is a minus 3x squared. So final answer is minus 3x squared e to the minus x cubed, or minus 3x squared over e to the x cubed. Now these two examples, 11 and 12, I put in here to help you see and make sure of your algebra. Watch the algebra here when you're moving things up and down with powers. Okay, example 13 now is just one of these, what's called implicit, just like 10 was. So here we go. Product rule. So write the first one down, take the derivative of the second one. Derivative of the second one is itself times derivative of the power, which is 1, tag on a y prime. Plus, write the e to the y down and take the derivative of the x. Derivative of the x is 1. Minus. Now watch this one. A lot of people make a mistake here. Watch this. Minus. I'm going to write the y squared down and take the derivative of the e. The derivative of the e is the derivative of the power times itself. Minus. Okay, I know the product rule says this plus this, but it's a minus times both of those. So it's a minus and then minus times a plus. And then we take the derivative of y, which is 2y, tag on a y prime, write down the e to the x. Okay, and then equals 5y prime. Now in the notes what I did is I solved this for y prime. So we grouped the y primes together. All right, we have y prime here, we have a y prime here, and we have a y prime here. So let's move these three over here to this side of this equal sign. So we have 5y prime. Moved across, we have a plus 2y, y prime, e to the x to the 5th. And moving the other across, we have a minus x, e to the y, y prime. Now on this side, it leaves us these two. So we have e to the y minus y squared times 5x to the 4th times e to the x to the 5th. So we factor out a y prime here, take a y prime out of this, and then divide that into that. And there are a few times when you need to know that, all right? So to solve for y prime, that's the algebra. Now let's look at the last example on the back of the notes. We want to find max minimum. Okay, find max minimum of, okay, it can be written x over e to the x squared, or it could have been written x times e to the minus x squared. And this is the way I think you should learn to do this. Don't do a quotient rule here. Go change it to a negative power, move it up, then do the product rule. All right, so here we go. Y prime is equal to x times e to the minus x squared times the derivative of the power, which is a minus 2x, plus derivative of x is 1, so this is e to the minus x squared. Now, I referred a while ago earlier that whenever you do these for max and minimum other applications, you're going to get this in both of them. So you're going to factor that out. Factor e to the minus x squared out, And what you get is a minus 2x squared plus 1. This part will never give you a maximum, minimum, or a point of inflection. So you don't even worry about setting that equal to 0. You set this part equal to 0 and solve for x. And when you do that, moving the 1 across, you get a minus 1 divided by minus 2. You get 1/2 is equal to x squared. So therefore, you get minus the square root of 1/2, and you get plus the square root of 1/2. All right? Now plugging in the square root of 1/2 in the original equation, your y value will be 0.429 approximately. And your minus will be the same answer, so it'll be minus 4.29. Okay, now let's take the second derivative. So the second derivative, okay, I'm going to do that right here. Okay, the second derivative would be, write the first one down, take the derivative of the second one, which is a minus 4x, plus, write the first one down, minus 2x squared plus 1 times the derivative of the second one, which is itself, times minus 2x. Now factoring out an e to the minus x out of this, all right, what do we have left? Well, we have this times that is a positive 4x cubed. And then this times this is a minus 2x, another one, so it's a minus 6x. All right? Now common factoring out, of which is 2x. So right here we get 2x times 2x squared minus 3. So points inflections are 0 and plus and minus square root of 3/2. So point inflection is minus the square root of 3/2. 0 and plus the square root of 3/2. All right, now watch this. I'm going to now take the minus the square root of 1/2 and put it in the second derivative and see if it's, well, that's a minus, so that's negative. Put it in here, that would be a positive 1/2 times 2 is 1, minus 3 is negative. So negative times negative is positive, therefore this is a minimum. If I put a plus 1/2 in here, this becomes positive. This is still negative, that's negative, so this becomes a maximum. And then checking on both sides of these, you get points of inflection. So looking at the graph there on the notes, you get a positive square root of 1/2, 0.429 is a maximum. Minus the square root of 1/2, minimum, points inflection at 0, square root of 3/2, minus square root of 3/2. And so that's what your graph looks like. All right, this concludes then tape 427 about derivatives of logarithms and exponential functions.